NASA says that Voyager 1 has become the first man-made object to reach interstellar space, the cold, dark region between stars.
Something strange is happening at the edge of our solar system. Voyager 1, the most distant object ever sent from Earth, has picked up a signal, structured, rhythmic, and coming from a place where nothing should be. It's not random noise, it's not interference, and it's not from any known source. As scientists dig deeper, one question becomes impossible to ignore. Has Voyager 1 stumbled into something or someone out there in the dark? Voyager 1, NASA's furthest traveled spacecraft, continues to make headlines decades after its launch. Having been in space since 1977, it remains the most distant human-made object from Earth. Despite being over 15 billion miles away, Voyager 1 is still sending back usable data, a testament to the robust engineering of a spacecraft built nearly half a century ago.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth.
Originally launched to study the outer planets, Jupiter and Saturn, Voyager 1 completed its primary mission in the early 1980s. It then continued its journey outward, passing the boundary of our solar system and entering what scientists call interstellar space. This region begins at the heliopause, a notional edge where the solar wind from our sun loses its strength and the influence of the interstellar medium becomes dominant. Voyager 1 crossed this boundary in 2012, making it humanity's first emissary to this unexplored frontier. Interstellar space is expected to be extremely quiet. This area beyond the heliopause is cold, thin, and largely devoid of the electromagnetic chatter found within our solar system. It contains only sparse particles, a few cosmic rays, and low-level background radiation. In essence, scientists anticipated that Voyager 1's continued journey would involve routine measurements of particle density, magnetic fields, and plasma waves. Nothing out of the ordinary. However, in recent months, researchers noticed something unexpected. The spacecraft, which is equipped with instruments to detect plasma waves and magnetic fields, began receiving a set of data that didn't fit the usual profile of interstellar noise. The signal was subtle and didn't raise immediate alarms. At first glance, it appeared to be a normal sequence of low-frequency electromagnetic pulses, something Voyager had picked up many times before, but upon closer examination, the data revealed a pattern. These electromagnetic waves weren't random. They followed a rhythmic structure, consistent in frequency and timing. Such a regular pattern isn't something typically produced by natural sources in deep space. In previous encounters, phenomena like solar wind bursts, magnetic field shifts, and interstellar plasma interactions caused fluctuations in the data, but these were usually chaotic or short-lived. The new readings stood out because they were consistent and repeated, almost like a ticking metronome. Initially, scientists considered the possibility of interference, a fault in the instruments perhaps, or some error in data transmission. Voyager 1 systems are old and the spacecraft is currently operating on a backup thruster system and limited power. It's not unreasonable to question whether an aging piece of equipment might misinterpret data or develop unexpected faults. But after thorough checks, engineers confirmed the instruments were functioning normally. The data wasn't a glitch, it was real, and it was coming from somewhere beyond the spacecraft. To understand the nature of these signals, scientists compared them to known cosmic sources. Space is filled with many types of electromagnetic radiation, from fast-spinning neutron stars known as pulsars to bursts of radio waves emitted by quasars. However, this new signal didn't align with any of those known sources. It wasn't a pulsar, which usually emits in short, sharp pulses. It wasn't a quasar either, which produces high-energy waves and is typically located around the centers of distant galaxies. Moreover, the region from which the signal seemed to originate appeared to be empty. According to star charts and observational data, there are no nearby stars, planets, or other cosmic objects in that direction. It's essentially a dark patch of space. That made the signal even more intriguing. The electromagnetic frequency detected was steady and unusually precise. This alone set it apart from background radiation or interstellar interference. Natural sources, even those that pulse or oscillate, often show irregularities due to interference from magnetic fields or dust clouds. In this case, however, the signal held its form consistently over a period of days, then weeks. Scientists began to realize that they were looking at something that didn't have an easy explanation. As is standard in cases like this, researchers went through the process of elimination. Solar activity was ruled out first. Voyager 1 is so far from the sun that solar radiation takes over 22 hours to reach it, and by the time it does, it's weak and diffuse. Even during solar flares or coronal mass ejections, the patterns of radiation do not match what Voyager was detecting. Next, they examined the possibility of distant interference from Earth or other spacecraft. But Voyager 1 is far outside the range of Earth-based transmitters, and no other probes are currently in its vicinity. Plus, the angle and strength of the signal didn't match the characteristics of reflected or scattered transmissions. It was, in essence, a signal that had no known source. What made the situation more compelling was the slow variation in the intensity of the waves. The signal wasn't just flat, it fluctuated gently over time as if responding to changes in its environment. That suggested a dynamic origin, something that might be moving or evolving rather than static or mechanical. At this point, scientists were not ready to make definitive claims. The space community is generally cautious when interpreting unusual data, especially when it comes from a single source. But the unique qualities of this signal, its rhythm, structure, and persistence, meant it could not be ignored. There's also a historical context that makes this situation fascinating. Voyager 1 was designed to be more than just a science probe. It carries with it the golden record, a gold-plated phonograph containing images, sounds, and greetings from Earth intended as a message to any extraterrestrial life that might encounter it. Though the likelihood of such a meeting was always considered remote, it shows that the mission always had a dual purpose: scientific exploration and symbolic outreach. And Voyager 1 begins receiving a signal that doesn't behave like a natural phenomenon. It naturally sparks curiosity. Could it be a coincidence? Possibly. Could it be the first sign of something artificial? That's a harder question to answer, but one that scientists now have to consider seriously. It's important to remember that the signal doesn't contain language, images, or any obvious markers of intelligent design. It's not a message in the conventional sense. What's being picked up is simply a structured electromagnetic pattern, one that suggests order but not necessarily intent. It may be a natural phenomenon we don't yet understand, a byproduct of some unknown cosmic interaction, yet the possibility that it could be more than that remains. In the world of space science, most major discoveries start with something that doesn't make sense. A measurement that's too strong, too regular, or too isolated from any known source often leads to breakthroughs in our understanding of the universe. That's what makes this particular moment so interesting. Voyager 1, an aging spacecraft well past its expected lifespan, may have stumbled across something genuinely new. This wasn't random noise. Over a period of several weeks, the signal gradually grew in strength before fluctuating again. These shifts weren't chaotic, but appeared to follow a loosely defined pattern, though not one that could be easily mapped against natural space phenomena. What raised eyebrows among researchers was the consistency of these fluctuations. Gave the impression that the source of the signal might not just be active, but responsive, possibly interacting with its surroundings or even with Voyager itself. Voyager 1 is not equipped to transmit commands or messages. Its role is observational. However, it does emit a constant, low-powered signal to Earth, primarily for navigation and data relay. This signal helps NASA determine its location and trajectory. Interestingly, as researchers looked more closely at the incoming data, they noticed that the detected waveforms weren't being picked up at random. They were arriving in a directional pattern, almost as if they were being aimed at the spacecraft. Most natural radiation sources, like stars or interstellar gas clouds, emit in all directions. Their energy spreads out evenly unless shaped by extreme conditions like magnetic fields or black holes. In this case, however, the signal Voyager 1 was receiving seemed to be narrowing over time, as though the source was adjusting its focus. That suggested something highly unusual, a directed signal. If this signal was indeed narrowing its aim and aligning more precisely with Voyager's position, it implied a degree of awareness, an ability to locate and follow a small spacecraft traveling through the vast emptiness of space. Voyager 1 is roughly the size of a small car and operates without active propulsion. Its path is stable and predictable, but still, being able to track it from such an extraordinary distance would require either highly advanced technology or something that exists entirely outside of our current understanding. While scientists were careful not to jump to conclusions, the behavior of the signal began to raise a serious question. What if the source wasn't natural at all? This idea, once pushed aside in favor of more conventional explanations, started gaining traction in some parts of the scientific community. The structured rhythm, the focused directionality, and the changes in strength all leaned towards something that could, at the very least, be artificially generated. One of the features that caught particular attention was the mathematical nature of the signal. After deeper analysis, data analysts found that the waveforms displayed self-repeating structures, what are known in mathematics as fractals. These are patterns that look similar at different scales, often used to describe chaotic systems, natural formations like snowflakes or coastlines, and even some biological structures. But in this case, they appeared in electromagnetic data, something that's typically chaotic and messy in deep space. The presence of fractal patterns wasn't the only unusual aspect. Within those patterns, researchers also noticed sequences of prime numbers that are only divisible by 1 and themselves. In scientific circles, prime number sequences have long been considered a possible hallmark of intelligent communication. Unlike binary pulses or Morse-like code, which might arise from natural magnetic fluctuations, prime numbers are mathematically distinct. They are universal and unlikely to occur by accident in a structured form. That doesn't mean an intelligent source is guaranteed, but the presence of prime sequences within a directed, repeating signal detected in a supposedly empty part of space is difficult to dismiss. It's a scenario that many researchers and thinkers in the field of SETI, the search for extraterrestrial intelligence, have theorized about for years. If an intelligent civilization wanted to announce its presence without relying on language or symbols, a mathematical fingerprint might be the most effective way to do so. If Voyager 1 had encountered something intelligent, the question became more complex. What exactly had noticed it? Could it be a machine, a signal relay, or perhaps something entirely unknown? And more importantly, was this a response, or had the probe merely stumbled into an ongoing process? Adding to the complexity was the fact that the signal showed signs of being layered. Within the primary waveform, analysts discovered a fainter pulse, oscillating at a completely different frequency. It had gone unnoticed at first, buried in the background static, and only became visible when the data was filtered and enhanced. This second signal didn't follow the same rhythm as the primary one. Instead, it showed irregular timing and small gaps enough to suggest that it wasn't part of the original transmission, but was riding along with it, possibly as an embedded message or secondary data stream. Further analysis revealed something even more intriguing. This secondary signal displayed time delays, small but measurable lags between pulses, inconsistent with a standard transmission from a single point. These delays matched the kind of spread you might expect if a signal was being bounced from one location to another across vast distances. In other words, Voyager 1 may have intercepted a relay. If true, that would mean the source wasn't isolated. It could be part of a network. A communication system that spans light years, using multiple nodes or points in space to relay information, isn't something that naturally occurs, at least not in ways we currently understand. This added a new dimension to the theory. Voyager might not be communicating with a single object, but instead passing through the edge of a larger structure, possibly a vast and ancient communications array, or something even more complex. While these ideas remain speculative, the supporting data could not be ignored. There were too many layers to the signal, too much consistency, and too many questions for this to be written off as noise. Some researchers began working on simulations to model what kind of structure or system could create such a signal. The possibilities ranged from automated beacons left behind by a long-gone civilization to advanced systems still in active use today. One especially compelling idea was that the signal represented a form of time-delayed communication. In this model, the signal wasn't intended for Voyager at all. It may have been part of a message sent centuries or even millennia ago, only now brushing past our small, aging probe. That would align with the concept of a civilization that communicates over vast spans of time, one not bound by human time frames of seconds, hours, or days, but by epochs. Voyager 1 is moving at roughly 38,000 miles per hour, which is fast by human standards, but slow in cosmic terms. It has taken nearly 50 years to reach its current position. If the signal it encountered is truly part of a relay or network, it may have originated from an event or object that hasn't existed for a very long time. The probe might simply be passing through the remnants of a larger system. There's also the question of the environment. Voyager's instruments, though limited by today's standards, are still capable of detecting gravitational variations in plasma density. During the same period the signals were being received, researchers began noticing small deviations in the spacecraft's path. These shifts weren't dramatic, but they were real and measurable. Tiny changes in velocity and direction that couldn't be explained by onboard systems or external known forces. The most likely explanation, given the absence of known celestial bodies nearby, was gravitational interference that would suggest Voyager 1 as being influenced by a massive object not visible using current observational tools. It might be a planet-sized body drifting in darkness, or something more unusual, a structure or mass that doesn't emit light but still exerts a measurable gravitational force. The idea that such an object could be present yet invisible isn't entirely new. Astronomers have long suspected the presence of so-called dark objects in the galaxy, including rogue planets, black holes, and other exotic phenomena. What makes this situation unique is that it appears Voyager 1 is not just near such an object, but interacting with a signal that could be tied to it. As researchers continue to study the data, the line between natural explanation and unknown phenomena remains unclear. There is still no direct evidence of intelligent life, but the accumulation of strange patterns, directed signals, prime number sequences, time delays, and gravitational anomalies all point to a set of conditions that demand further investigation. This unexpected cutoff added another layer of uncertainty. It raised immediate questions. Had the source of the signal moved away, or had it shut down? Could it have been a temporary alignment or an event that had now passed? The timing was unsettling. The strongest and most structured part of the signal had ended not long after Voyager's instruments detected slight shifts in trajectory and gravitational anomalies. And these events, already puzzling on their own, now appeared to be connected to the silence that followed. The end of the signal did not bring closure. In fact, it only deepened the mystery. Shortly after the transmission stopped, Voyager 1's instruments began picking up residual energy, strange fluctuations that defied calibration. These anomalies weren't part of the original signal, but seemed to linger in the probe's systems like an echo. Engineers at NASA attempted to reset and recalibrate the instruments, but the data continued to show small, persistent deviations that could not be traced to any internal fault or external influence. This residual effect resembled a sort of electromagnetic fingerprint. It wasn't strong enough to be considered dangerous or damaging, but it was clear that Voyager had passed through something unusual, something that had altered its environment, even if only temporarily. It was as if the encounter had left a mark not only on the data, but on the probe itself. A machine designed to gather data had recorded an event it could not fully interpret. What was especially unusual was the nature of the energy signature. It didn't resemble the outcomes of known space events like solar storms, radiation bursts, or interactions with cosmic dust. Instead, it sat in a category of its own. It was steady but variable, not quite random, yet not fully patterned either. Scientists described it as non-natural but non-deterministic. A phrase that, while vague, accurately captured the limits of current understanding. With the signal gone and only these faint traces remaining, focus shifted from real-time monitoring to retrospective analysis. Teams began combing through the data, looking for anything they might have missed, details hidden in the signal's modulation, unexplored frequency bands, or subtle timing differences. But even as they searched for clarity, another idea began to surface. Perhaps what Voyager had encountered wasn't meant to communicate at all. Maybe it was simply observing. That thought, quiet but powerful, led to a shift in perspective. If the signal had been deliberate, the fact that it had suddenly stopped could be interpreted in many ways. It might have been an intentional response, a kind of acknowledgement followed by silence, or it might have been a test, a brief interaction designed to measure how Voyager would react. And if that's the case, then perhaps the most chilling question isn't whether something sent a message, but whether it received one. Voyager 1 continuously transmits its location and data back to Earth. This isn't just for scientific purposes, but also for basic tracking. That signal, though weak, is detectable under the right conditions. If a structure, object, or entity was sensitive enough, it could have picked up Voyager's presence from a considerable distance. In such a scenario, Voyager might not have intercepted a signal, it may have triggered one. Speculation in scientific circles, although carefully restrained, has started to consider less conventional possibilities. One idea gaining quiet momentum is that Voyager may have entered a region of space not as empty as once believed, perhaps a boundary of sorts, or even a threshold. This region could be monitored or patrolled by some form of intelligence, not necessarily hostile or even active in the way we understand action, but aware. This intelligence, if it exists, might not function the way humans do. It might not be interested in communication, exploration, or contact. It might simply observe. If so, then Voyager's arrival could have registered like a ripple on a still pond, not threatening, not urgent, but noticeable. Some scientists have drawn comparisons to Earth-based systems, passive radar stations, deep-sea listening posts, or weather sensors that constantly monitor without intervening. Could such a concept apply at a galactic scale? Could there be passive systems in space designed to detect anomalies or record movement? If so, what Voyager encountered may not have been a being or a civilization, but a tool left to run autonomously over long periods of time. Others have gone further, proposing that the object, or whatever generated the signal, might be alive in a way we cannot yet define, not biological, but sentient through other means. Some have described this idea using terms borrowed from physics and systems theory, that it might be an awareness embedded in electromagnetic fields or in gravitational wave patterns. Not a mind like ours, but a form of cognition adapted to the environment of deep space. This idea remains speculative and difficult to explore using current technology. Voyager 1 itself can't be redirected or upgraded. It's operating with power constraints, limited instruments, and no real-time communication capabilities. Even if scientists develop new theories or detection methods, they have no way to send them to the probe quickly or gather new data in response. That limitation has sparked conversations about the future of space exploration. If Voyager has truly encountered something outside our current models, it highlights how little we know about the spaces between stars. There are already proposals for next-generation probes, faster, smarter, and capable of autonomous decision-making. These new spacecraft might be able to navigate anomalies, adjust their own instruments, and even send targeted queries. But for now, Voyager remains alone, a solitary witness to a mystery that may never be fully understood. On Earth, the implications of the event have begun to ripple through not just scientific communities, but also philosophical and cultural discussions. What does it mean if a human-made object has interacted with something intelligent or structured far beyond our solar system? How should we interpret a signal that appeared behaved with precision, and then vanished without explanation. Some argue that it's a reminder of how little we understand about our universe. Despite all our technology and achievements, we are still newcomers on the galactic scale. Others suggest it may be time to rethink how we define life, intelligence, and awareness. Not all beings or systems need to communicate with words or symbols. Some might express presence simply through patterns, rhythms, and energy. And then there are those who raise caution. If the encounter was real and the signal was directed, then it's possible Voyager wasn't just an observer but a participant. Whether the interaction was intentional or accidental, it may have drawn attention to Earth. That's a sobering thought because, unlike Voyager, Earth cannot quietly slip through the cosmos. Our planet emits a steady stream of radio waves, visible light, and even physical probes. We've been announcing our presence for nearly a century. Whether that announcement has been noticed and what response, if any, might follow are questions that will likely remain unanswered for years, if not decades. Voyager 1's journey continues, but its moment of contact, or near contact, has left scientists with more questions than answers. As mission controllers continue to analyze the lingering anomalies, one thing remains certain. The encounter, whatever it was, challenges our assumptions. Space was once thought to be mostly empty, a dark expanse filled only with stars and the occasional planet. But Voyager 1 may have brushed against something else, something more complex and structured than we expected. The silence that followed is perhaps the most powerful part of the entire event. It didn't bring resolution. Instead, it left behind a sense of anticipation, of possibility, and of the vast unknown that still surrounds us. Voyager's signal, weak but persistent, still travels back to Earth, and as long as it does, it will continue to carry not just data, but a story, one that suggests the universe might be more connected, more watchful, and perhaps more aware than we once believed.